In this problem, we will try to find the area that lies outside the cardioid r equal to a into 1 minus cos theta and inside the circle r equal to a sin theta. Recollect, the area for the polar format is given by double integral r dr d theta. Now, for plotting of the curves, cardioid. What is cardioid? Cardioid is an heart-shaped curve. And we have been given the cardioid as r equal to a into 1 minus cos theta. When you have a minus sign over here, the heart will lie to the left side of the axis. And when you have this r into 1 plus cos theta, so instead of minus, if you have 1 plus, then the heart will lie towards the right side of your axis. Now this is going to be to the left side of the axis, and inside the circle r equal to a sin theta. How will this circle a sin theta look like? It is a circle which is placed on the top or on the upper portion of your axis theta. Now let us get the point of intersection for these two curves. At which point do these two curves meet? So how to get the point of intersection? Solve these two curves simultaneously. R equal to a into 1 minus cos theta, r equal to a sin theta. Since r is the same, a into 1 minus cos theta is the same as sin theta. Now 1 minus cos theta I can write as 2 sin square theta by 2. And sin theta I can write as 2 sin theta by 2 cos theta by 2. 2 and 1 sin theta by 2 can be cancelled off, leaving you with sin theta by 2 is cos theta by 2. So bringing it to one side, tan theta by 2 is 1. When will tan take the value 1? Tan takes the value 1 for pi by 4. So we have tan of theta by 2 equal to pi by 4. So we will have this to be equal to, so tan of theta by 4 will be equal to pi by 4. So what will be theta equal to? Theta will be equal to 2 can be cancelled off. So you will have it as pi by 2. Okay. So the value for point of intersection of the cardioid and the circle a sin theta will be at the point theta equal to pi by 2 and theta equal to 0 degree. Okay. So now what is the area which is required? The area is lying outside the cardioid. Which is outside the cardioid? Outside the red portion. And inside the circle. Which is the circle? Inside the green portion. So the area for integration is the outside of the red circle and the inside of the green circle. So when we consider this, your r begins at the red portion, which is given by, what is the red portion? The cardioid, a into 1 minus cos theta. It moves and it ends at the right portion. Which is the right portion? The circle a sin theta. So r varies between a into 1 minus cos theta to a sin theta. Now how about the angle? So it is in the first portion with theta equal to 0 over here and theta equal to pi by 2 over here. So when the angle is measured in the anticlockwise, theta varies from 0 to pi by 2. The function to be integrated is r dr d theta. So we move on to the next slide. To evaluate the area 0 to pi by 2, a into 1 minus cos theta, a sin theta, r dr d theta. 0 to pi by 2 is kept as such. R on integration gives you r square by 2. Apply upper limit minus lower limit. 1 by 2 is taken common outside. R square. So a square sin square theta minus r square for the lower limit. A square 1 minus cos theta the whole square. A square is common. Take it outside. A square by 2. So this is sin square theta minus 1 minus cos theta the whole square. Use a minus b the whole square. A square plus b square minus 2ab. So 1 plus cos square minus 2 into 1 into cos theta. Again the sin square theta can be split as 1 minus cos 2 theta by 2. And this becomes minus 1. How can you split this cos square theta now? Similar to your sin square theta, instead of this minus sign, you will have plus sign. So, what is cos square theta? 1 plus cos 2 theta divided by 2. And now the last term, minus of minus is plus 2 cos theta. Now, let us collect all the constant terms first. 1 by 2 minus 1 minus 1 by 2. So, 1 by 2 and minus 1 by 2 cancels off, leaving you with minus 1. Now let us collect all the cos 2 theta. Minus cos 2 theta by 2, and here there is a minus cos 2 theta by 2. Okay, minus 1 makes it as minus 2 divided by, already there is a 2, so this gives me minus cos 2 theta. And the last term which is available here is 2 cos theta. So now this has to be integrated with respect to the variable theta between the limits 0 to pi by 2. So we move on to the next slide. A square by 2, 2 cos theta minus cos 2 theta minus 1. I am just rearranging positive term to the first and then followed by the negative term. Now this on integration with respect to theta. What is that? 2 is there. Cos theta on integration is sin theta. Minus, what is cos 2 theta on integration? Sin 2 theta by 2. And what is minus 1 on integration? Minus d theta on integration is theta between 0 to pi by 2. And now apply the limit. Upper limit is pi by 2, lower limit is 0. Since we have sin 0 is 0, sin 0 is 0 and theta is 0, my lower limit will entirely vanish. We will concentrate only on the upper limit. What is upper limit? 2 sin theta takes pi by 2 minus sin 2 times theta takes pi by 2 divided by 2 minus theta takes pi by 2. Now what is this here? It is sin pi by 2. What is sin pi by 2? It is sin 90 degrees. What is sin 90? We know that sin 90 is going to be equal to 1. So it is 2 times of 1 minus, what will happen to the second term? 2 and 2 cancels off. Recollect that sin n pi equal to 0 for all values of n. So what will be sin pi, which is 1 pi, that will also be 0. So the second term also becomes 0. And third term we have minus pi by 2. Hence the final answer that lies outside the cardioid and inside the circle is a square by 2 into 2 minus pi by 2 square units.